Hello. In this video, we're going to be taking a look at the quadratic formula and how it can be applied to solving quadratics, finding roots, and other various things. So the quadratic formula, which you see in the middle of the screen here, is something that you don't have to formally memorize. It is something that you are provided with on the Regents and any tests you take in class. You are responsible for knowing, however, how to use it. So knowing that A, B, and C refer to the coefficients when the quadratic is written in standard form like this. Simply just the coefficients, so obviously we don't include the x squareds or the x, and it does have to be set equal to 0. So oftentimes there is some behind the scenes work of getting it set up like this before you plug in. So we're going to be taking a look at two examples, one where we're solving for simplest radical form. Oftentimes with the quadratic formula, it can work out nicely if you get a perfect square under the radical, but more often than not, you have a radical left over, so we'll talk about how to simplify that. And then the second example we'll take a look at, it might ask us to find it to the nearest tenth or actually calculate what that ugly irrational expression is equal to. So let's jump right into one. It says solve for all values of x and express your answer in simplest form, simplest radical form, I should probably say. So right away, this is a kind of cue that this isn't going to be factorable. If they're mentioning radicals in the directions, this certainly isn't going to be one where we could use our zero product property. So completing the squares in there, quadratic formula obviously will always work, and that's what we want to practice here. So let's try quadratic formula. To first do that, we are going to have to simplify this. Even if we were doing basically anytime you're solving a quadratic, you do want to get it in standard form, see what you're working with before you decide just by looking at a problem. It's oftentimes it's pretty difficult to do just in the beginning. You want to get it cleaned up, and then you can make a good decision about what's the most efficient technique to do. So right now I'm setting up a box just to help me multiply the left-hand side of this out. Could foil if you'd like. Box keeps things kind of organized. Okay, so I'm going to get 4x squared minus 6x after I combine the negative 10 and the plus 4, and minus 10. And that's going to be equal to 3. Okay, like I said, you could have just kind of foiled here if you wanted to, just if you're a little bit more comfortable and you don't want to waste the time in actually drawing the box method out. It can certainly help organize things. Sometimes with the quadratic formula, you make an error in the beginning and then it messes everything else up, and then it's a long problem to begin with. So you want to be careful. It doesn't kill you to save kind of 30 seconds there. Before I jump into the quad formula, I do want to set it equal to 0. So my last step before I get moving on the quad formula is just to subtract that 3. So I'm ultimately going to have this. So now it's in standard form. I can clearly label and identify what A, B, and C all are. So A will be 4 in this case. I include the negative sign, so B is actually negative 6, and same thing with C. Okay, the quad formula, which I'll rewrite up here, once again will be provided to you, so no point in this video is dedicated to like, hey, this is how you memorize the quadratic formula. Sometimes even just by doing it, you see you kind of subconsciously pick it up regardless. And now we're going to plug in. We do want to be very careful. When you plug in, there's a lot of room for error with the quad formula, particularly like double negative signs, squaring negatives, things like that. Can certainly make things confusing, so you want to make sure you're using parentheses. I don't know why I put this so far. Whenever possible, and obviously you're using your calculator for all this as well. This right here is an important piece, the b squared. When we square something, notice how I put that in parentheses, because if I just write negative 6 squared, don't obviously do this, but if I just wrote this, more likely than not, that's exactly how you're going to type it into your calculator. And your calculator is actually going to say negative 36. And your calculator is correct in the way it's interpreting that. It's treating it as 6 squared and then multiplying it by -1. Okay, obviously, anytime you square something, just use common sense, the result should be positive. Okay, so if you just want to imagine, however you want to visualize that, b squared should always be positive there. Use parentheses or just think about that concept itself. Definitely one of the top 3 mistakes that I see with people plugging in that b squared component. Minus 4ac, so minus 4 times the 4 for a, and the c is -13. And the radical is where you can see it gets kind of messy. We're going to have a double negative, I see already. I like to figure out what that's equal to. Obviously, the front is going to be 6. I see a lot of people forgetting the plus minus as well. Don't just think it's like 6 radical. There is a plus minus there, so don't lose sight of that. And underneath the radical, I would recommend actually kind of like typing this in as a whole string on your graphing calculator as you're doing that, or as you're doing a problem on your own. I'm just going to do the math here myself. So we're looking at 36 minus that's 16 times -13. This is going to turn into 36 plus, and 16 times 13 is, what is that? $208. Okay, so 36 plus 208, we're looking at 244 underneath our radical. So this is what I have so far, and this is what we were mentioning earlier. It said simplest form, so I want to try to find perfect squares that go into 244. And once again, just a little reminder here, this was a double negative. That's why it turned into, you might be saying, why did we add 208? It was minus, and then the result of the product was -208. So minus -208 turns into plus 208. That's how we get the 244. So now, with the radical, right away I spot that a 4 can certainly go into 244. And if we do factor out a 4, we have 61 left over. Just do that through division. Okay. The radical 4 becomes simply 2. And this is what we're left with. And now there's one last step here. And this gets a little tricky. We can divide out a GCF of 2. The only rule with that is all 3 of those must have that GCF in common. If you think of it, the 6 is being divided by 8, and so is that 2 radical 61. So it kind of has to match both of them. Oftentimes you'll see just like that number out front and the denominator have something in common. All 3 of those have to have some common GCF. So our final answer is going to be 3 plus or minus. 1 radical 61 is the same as just saying radical 61 by itself. 1 as a coefficient is kind of redundant, so we don't need it. Doesn't hurt to put it, but not needed certainly. And that would be our final answer. Okay, so this is an example of one where we're simplifying a radical to ultimately arrive at our answer. And you see, obviously, based on what we got, factoring probably wouldn't have worked out. Even completing the square would have been quite ugly here, looking back at what we had once it was in standard form. We would have had to divide out a 4 and had a bunch of fractions left over. All of a sudden, that CTS step of filling in the box can get kind of sloppy. So quad formula was, obviously we're practicing it, but it was also the best approach in this particular problem. Okay, and one more example we're going to take a look at. In this case, we're solving it, finding the roots, and we're doing it to the nearest 10th. So from what we've learned in the past, roots are where the function is equal to 0. This is what roots mean. That's another way of saying the x-intercept. It's where the function literally will equal 0. So that's what we're going to do first. And the good news there, we don't have to do any cleanup. We're already in standard form. Okay. And now I'm going to label what A, B, and C are, just like we did earlier. I'm going to plug into my quad formula. I want to make sure to use parentheses like earlier whenever I'm plugging something in. I want to be extra careful with the b squared. And I never make the radical quite large enough. Let's see if I did here. 2 times 23, 4ac. Just do a quick double check too once you get to this step that sometimes people swap an a and a b somewhere just by accident. So just make sure you have everything in the right spot. Okay, so now I'm going to have 4 underneath, plus or minus. And I'm going to type in the entire radical on my calculator, making sure that I type it in how I wrote it, which was correct with parentheses. And I end up getting underneath, or as a radicand, 12. Okay? And technically we could stop there and type it in our calculator because it said nearest tenth, but for good practice, if we want to practice simplifying, we could pull out a radical 4. And radical 4 we know is 2. And now I could actually pull out a GCF. The 14 and a 2 have a 2 in common with that denominator as well, giving me a final answer of 7 plus or minus radical 3 all over 2. Okay, so that's a good answer. It does say what is this to the nearest tenth. So we're going to have 2 answers and we want to round them. One where we're adding radical 3 and one where we're subtracting radical 3. And what you would do in the calculator here is important. If you just literally type in 7 plus radical 3 and then hit the divide by 2 button in one string, your answer is actually going to be off. So you would want to do one of 2 things, which I'm going to show you in a second. You would either want to type it in with parentheses to indicate that you're adding these or subtracting them when you're doing the second answer, and then dividing them by 2. Or I like to actually enter this kind of separately. I add 7 in radical 3, I hit enter, and then I divide by 2 just so nothing's kind of broken up there. And you'll see, so this is what I type in. 7 plus radical 3 divided by 2. So this is actually one answer right here. Okay, and then I do the other version where I'm subtracting the plus minus. So now I'm minusing radical 3, and once again I hit enter and I divided by 2. So this is my second answer. Okay, so rounding each of these, we're looking at, to the nearest tenth, 4.4 and 2.6 approximately. So around 4.4 and 2.6 were our roots. Obviously they were irrational, so these are rounding, but they did say to the nearest tenth. Okay, it is important how you type it in. Like I said, if you just as with the b squared, if you don't include a parentheses, things can obviously look good but lead to a wrong answer. Okay, so this was a video on the quadratic formula. Hopefully this helped. The setup is very important. Using the formula and knowing how to use the calculator, all crucial steps when using the quadratic formula. If you have any questions, be sure to let me know. Thank you.